Go. Hello? Hello, Mr. Harry, Mr. Ryan, right? What have we talked about last lessons? What have we talked about last lessons? Just give me a keyword. Games, yeah, well done. And we talk about game, okay? Game theory, okay? We talk about the number halving game, yeah? Number halving game. Given a number, yeah, you can subtract 1 or you can divide it by 2, and whoever gets to 0 wins, yeah. And we also talk about the tic-tac-toe, alright? Tic-tac-toe. Okay, how do you spell tic-tac-toe? Tic-tac-toe, okay? Yeah? Yeah? We talk about the game terminologies, yeah? We have to talk about terminology, the state, yeah? State. We have a start state. The state is describes the current status of the game, like what's the state of the game, yeah, like who's going to play next, yeah, start state. We talk about what? We talk about is end. So this function will return if the game can be continued or not, right? So if the game has ended, so if it's a 0. Usually, we give a 0 to a game who is, nobody wins. It's a draw, okay? And then
that's only for tic-tac-toe.
Tic-tac-toe, and then, yeah. Because the number game, there's no draw, right? Yeah? Somebody has to win for the number halving drawing, okay? Number halving game. And then we have a utility function. Utility function describes that the whoever win in the end game only applies to the end game, right? And then we also have what? We also have a what kind of element? So state is an utility and then success. Okay, success. So given a state and then given the action, and you need to tell me the next state. Okay, yeah. Can you not walk around here? And also we have the action. The action for the number halving game is only two action. Either you divide or you subtract, right? So these are the basic elements. What else? So this is the two-player zero-sum game. Two-player, yeah. Each player takes turn. Like I play one, you play one. Takes turn. Zero-sum. Somebody wins, the other has to lose, right? I win, you lose. You win, I lose. Okay. Yeah. And then it has to be. Everybody knows exactly the same information on the board. On the game, right? So it's not like a poker card, right? So I don't know what's on your hand. You don't know what's on my hand. But on the chess, everybody knows share the same information, exactly the same. Like number halving game, the state is the number, and who's playing next, right? Okay. So today we just do a little bit review and using these 5. Okay, these 5 terminologies to describe the tic-tac-toe. Okay, the tic-tac-toe. First of all, for the start state, what's the tic-tac-toe start state? So how do we describe a tic-tac-toe? I mean, how do we describe a tic-tac-toe? So what's tic-tac-toe?
It's a square.
How many square?
9.
Okay, so a tic-tac-toe. Okay, so 9 square. 3 by 3. So we can describe a tic-tac-toe by a 3 by 3 array, right? And then who's next? Who's going to play next? So we have 2 players, yeah? The first one we call it agent, and the other one is called opponent, right? Yeah?
Wow.
Okay, so the state will be at the beginning. So at the beginning will be the empty. So we can put a 0. Okay, so if we put a 0, it means it's empty. It's not occupied yet. But
that would be confusing because because they're circles.
That's good. But how do you put I understand your point. So let's just use the number 0 to means that not occupied. It's empty.
Just do a 0 with a dash in it, like computers.
Yeah. That's okay. That we have many ways to describe it. But if it's a cross. Okay, so let's say if we use 1, because look, usually we use the +1 to do this agent, and opponent we use the -1. Okay, yeah, because look, remember why is +1 -1? We have this we pretend infinity if agent wins, and if opponent wins, we return minus infinity. Okay. So look, 0 means the not occupied. 1 means the agent occupied it. Yeah, this is agent, for example. Yeah. -1 means the opponent. Okay. Of course, as you said, we can use just the character string. Yeah. If you say okay, empty is empty, and then you put an X or put an O. This is also okay. Okay. But we use these just to make it simple when we want to calculate the utility. Make sense?
Yeah.
Okay. So start state. Okay. So let's just quickly implement this. Okay. Class tic-tac-toe. Okay. TTT. Okay. Object. Okay. Then define
Ow.
init. This is the constructor. Constructor is called when the when the TTT class initializes the object. Okay. It's a constructor. What's constructor means? Constructor.
Build stuff.
Build stuff. Yeah. It's like look the object template.
For the builder.
Class. We talk about this object-oriented programming. Yeah.
Yes, you can.
Class is the object template. Class is the object template, and we use the object template to create objects. So when we create an object, this init function will be called. Right. So let's say class person, class human object, and define init, and then we can say Eric equals person. Yeah, and then when we use the object template person to create an object, this function will be called. Okay. So at the beginning, with this code, we don't actually need to pass any parameters because this 3x3, this tic-tac-toe game is the deterministic, right? It's there. I mean, we all know what is a tic-tac-toe game. Yeah? It's 3x3, and then only cross and circles. So at the beginning, so we define a self dot. Let's say, what do you want to call this? Grid. Squares.
T-square.
Squares. Okay, so let's call it squares.
No, T-square.
Squares. Okay, squares. At the beginning, 0 times 3,
Waffle.
and then 4 underscore in range 3.
Cheese. It's a solar panel. Cheese.
Okay, so look, we define a two-dimensional array, right? 0 at the beginning we initialize the squares to 0. 3 rows, each one has 3 columns, 3 elements, 3 rows, 3 columns. Okay, that will be okay. And then we need to define define the start state. Okay, start state. Can I start? Self. So actually this would just return a tuple. A tuple. What is the tuple? Remember? Tuple.
You used to call it tuple.
We're done. Yeah. Tuple is the.
I'm good at memorizing.
You're very good at memorizing it. Yeah.
Thank you very much.
Okay. Tuple is immutable array list. Yeah. What's immutable?
You can't change it.
You can choose it. Okay. So return the tuple. First one is the player. Let's say +1 is agent, and then we want to return a state. Okay. Return a state. So basically we want to return this thing. So I'm just going to copy this here. Okay. Okay. So now start state. We have start state. We have implement the start state, and then define. We have what do we have? We have is end. So how do we implement this is end? How do we check if a game has ended?
If either all of the squares are filled or someone got three in a row.
Okay, so first of all we decouple the state into player because this is a tuple, yeah, for the tuple. The player and the actual state. Okay, so we want to check what? We want to check if the what?
If all of the squares are filled or if there's 3 in a row.
That's right, yeah. Okay, so we want to find out if there are 9, all the squares are filled, right? So we can say, how do we check it? Okay, so we can say, look, I'm not going to write here, okay, it will be too much code here. So one easy way, we can just brute force because only 3 times 3. So we can say return S0 equals S0, 0. Right, come on. So first of all, we want to check what? First of all, we want to check if all the squares are occupied. So we want to check if all the squares are occupied. So which one is what? Yeah. So one way we can do it is because look, we're using 1 and minus 1. Let's accumulate all the values, absolute values of the squares. So if the squares are fully occupied, the value should be equals to what? Which number? Absolute value. So I want to 9. Well done. So that's right. So first of all, I want to get the value. So I can say, okay, so the value sum. I can say sum ABX x for x in. So I want to sum up each one. So sum up R. Okay, so let's say, and then I need to do this sum x for x in R for R in this S. Okay, for R in S and then for x in R, I want to sum it. Sum this needs to be if this is 9, then we return 2, right? Obviously, okay. Yeah, return 2. Right? So we want to sum up all the elements, the absolute value. We put the absolute value here because we have minus 1 and we want to count how many slots are occupied. So if the squares are full, then all the number will be 9. Okay? And now if not, then I can check what? So I have to say, look, for R in range 3. Yeah, we want to check each 3 rows. Right, each 3 rows. So for R in S, okay. So we go through each row and then if R0 equals R1 equals R2, okay. So we just check each element in each row, and then return true. Okay, this is checking the row, and then we also need to check the columns. Yeah. Check the column. Remember, we talked about how to transpose a metric, yeah, using the zip function. So we can just zip it, yeah. We can say for R in zip star S, right? So we zip it, we transpose it, and then this is the same. If we just copy here, this is the same. And then for how many diagonals we need to check? 2. So we just further need to check if R00, if the S00 equals S11 equals S22, or if S02 equals S11 equals S20, then return true. Okay, this is if n. Okay, and the action. How do we define the action? Action taking a state. Taking the action. So how do we take the action? So what's the action? Action describes that what's the next move for a player, right? Yeah. So look at action. So S. First of all, I need to decouple the state. Player S equals state. Yeah. So now look, I just need to do what? Player. Now current player is player, so the next player is minus player. Yeah, we negate the sign. So current is the agent, so next one is the opponent. If the current player is opponent, the next agent will be next player will be agent. But the thing is that the action will be the all unoccupied slots, right? If it's unoccupied, I can put a cross or circle there, right? Am I right? Yeah.
Yeah, you can do your team.
Yeah, I know. For example, now current state is agent, and the next one is opponent. But for both agent and opponent, they are also looking. They can place either the cross or circle in the unoccupied slots. Right? So first of all, I need to put it in the answer. Okay, this is the list, and I need to go through for. Okay, I'm not going to write it here. For For what? For R in range 3, for column in range 3. If SRC equal 0, then we can append RC. Okay? Append RC. This is action. Okay, this is action. And what else? Start state is end action and utility. Okay, utility. So how do we implement a utility function? Utility only applies to end game. Okay, end state. So we first of all need to apparently this takes the state parameters and we need to decouple it. Yeah. So player, everybody, come on. Player S equals state, decouple it. Another state. So I want to assure this state is ended. So assert self dot is end S. Okay. So now the game has to be ended. Right? So it's ended now. So the utility. So the utility. So okay. So this one, if it's ended, so now I also need to. So we also need a function to tell us who wins, right? Who wins, right? So this function. So the logic will be similar here. So you're looking for, maybe we can refactor a little bit. It's n. Instead of return true or false, we also return a number. If it's 0, it means a draw. If it's 1, it means the agent wins. If it's the -1, the opponent wins. So this is basically, yeah. So basically we can reuse this bit of code logic here. This is a utility function, and the successor is actually very genetic template. Okay, successor takes a state and takes a action, and it just returns the next state. Okay, so then player S equals state. We also need to decouple the state, and then this returns the action. Yeah, this is the action. Action would be the what? The action will be the pixel, which coordinate, which slot you're going to place. Okay, so then we can just return. We just say this action 0 and action 1 equal what? Equals to play to play current player. Okay, current play, and then return minus player. Okay, because current player is agent, and the next one is minus play, and then return the new state. Right? Okay. So now in this case, we just define the tic-tac-toe game using these 5 terminologies. The start state is end, action, yeah, action, utility, success. Okay. Yeah. Any questions so far? Any questions? Too much noise or okay. Okay, come on. Yeah. Okay, that'll be it for today.
Bye.
Bye. Okay. You.